right, so our topic today is measurement of angles. First off, we need to get some vocabulary down. You just should have finished your project on radians, and you cut out some circles, you measured the radius with the string, and you came up with some observations about what happens when you create angles and things like that on the circles. All right, so you did something like this. You created the X and Y axis on your circle, and you drew a line to the out to the end of your string, and then you brought your string back this way, and then you drew uh, another line up from the center to create the subtended arc. Okay, so the subtended arc was created by an angle. When you're here on the x-axis, the positive side of the x-axis, not the negative side over here, but the positive side, that's called the initial side of your angle. And then you're going to go counterclockwise would be positive. Okay, so you're coming over here, and this is called the terminal side. And notice the origin is the vertex of this angle. Okay. Okay. Counterclockwise rotation represents a positive angle. I said that. So then clockwise would be a negative angle. And we use these Greek letters, theta, beta, and alpha, or we can use capital letters to denote angles. And we can measure these angles in degrees or radians. Either one is okay. Okay, so a radian measure is the number of radius units in the length of the arc. So when we did our circles in the project, we took the radius, right, and we put that piece of string that represented the length of the radius on the circumference of the circle, and we measured an angle that way. And this should be the length of our arc, right, is also the length of the radius. So this would give us, that would be 1 radian measure. All right, so we have this measurement here, or ratio. We said the side, or excuse me, the length of the arc divided by the radius is the radian measure of the angle, which in this case is referred to as theta. Okay, so what we want to do here is we're going to say that that's going to be 5 divided by 2. We could leave it like that, but more likely we'll go ahead and make it a decimal, so 2.5. Okay, and this is not degrees, right? This is radians, so we don't put any degree symbol up here. All right, and then here S is R, the radius is R, so our ratio is R to R, which is 1. Okay, so the 1 radian is equal to the measure of a central angle being here, whose arc has length of R. All right, so we have to convert between degrees and radians because, you know, sometimes we need degrees, sometimes we need radians, depends on what we're doing. So we know that 360 degrees is 1 revolution. So when we're talking about a revolution, we're going around the circle, which is also called the circumference. Okay, so circumference is also denoted by the formula 2 pi r. And if we simplify that, right, r divided by r is 1, so that's simply 2 pi. And all the while, it's equal 360. So that means that pi is equal to 180 degrees. So that's our relationship. 180 degrees equals pi. So when we're setting this up, we're going to say that x degrees, okay, is in relationship with pi over 180 degrees. Okay. The reason we need that is degrees divided by degrees, the degrees are going to effectively cancel, right? And then if we have radians, so we have x radians. We don't have a symbol for that, so we just write the word. Okay, I'm going to abbreviate x radians. Then in our relationship, 180 degrees needs to be on top because the pi represents 1 radian, right? And so, actually pi doesn't, so the radians, pi is a measurement of radians, not 1 radian, but the radians would cancel, leaving us with degrees. All right. Then, so if we're going to convert negative 225 degrees to radians, we'll set it up negative 225 degrees. And then it's going to be to pi over 180 degrees. Okay. So if we're multiplying that across, so that's going to be negative 225 pi over 180. Okay. So then we just need to reduce this negative 225 over 180. I can see it's divisible by 5. Turns out it's also divisible by 9, and we'll reduce down to negative 5 pi over 4. Okay. So if we were going to convert 50 degrees to radians, we're going to start with 50 degrees. And we're going pi to 180. So again, we'd have 50 pi over 180. Use our great reduction skills, and we get 5 pi over 18. Okay. Going the other direction from radians, negative pi over 3, 2 degrees. Okay. We're going to set it up negative pi over 3. Stretch it out a little bit, and then it's 180 degrees over pi. Okay, so we're multiplying across. We have 180 pi, or negative 180 pi, pardon, over 3 pi. And we know pi divided by pi is 1. Negative 180 divided by 3 turns out to be negative 60 degrees. Okay. And then convert 3 pi over 4 to degrees. Same idea, 3 pi over 4. And we have 180 over pi. Okay. So gonna take a little judicious, not writing out so much. 3 times 180 divided by 4 is 135. And then we have pi divided by pi, so it's just going to be 135 degrees. Okay, so that's it for converting.